Hello, everyone. Welcome to our meeting, MLGdańsk online meetup. Our guest today is Amit Dua from south of Poland, and he will be talking about the evolution of machine learning. So, Amit, the floor is yours. Yeah, please present your talk.
Yeah, thank you, Marcel, first of all, and thank you for inviting me to give a session about machine learning. So, hi everyone. I will be I'm also a PhD student at Visa and also working side by side. And I'll be presenting today about machine learning. So, what are the application? What are the basic concepts? And we will also see an example, maybe using regression analysis to solve a particular problem. So we will be talking about evolution of machine learning today. So what is machine learning? So it's like all about finding the patterns in the data. So uh, like in the before in the past we used to like a long course, and then we have to implement something. But with machine learning we have to operate with the data, and machine will choose a particular algorithm to perform some analysis and give us some output. So it's like we are not writing anything, any particular codes. We are just supplying the data to the machine, and machine will do the predictions and take a valuable decision for us. And I mean, we are not explicitly programming anything to solve a particular problem. So, so we can see the diagram. So this is a traditional method of doing some analysis on a problem. Like we used to have some traditional programming. We used to give data input and then make program, and then we will get the output. But with machine learning, we will give some data as an input. We will also because machine learning is we'll choose an algorithm based upon our data set, and we will also try to tell what type of data it is. And with that learning, the machine will be able to predict the future values when we are supplying the future data. So it is in the like it is making a program or algorithm to uh, operate on those data values and give us the results. So, so this is the working model of machine learning. So what we are doing, we are gathering the data. I mean, and definitely with the machine learning, we need a lot of data to operate on it, because first we have to train our algorithms to operate, and we will then test our data to for the machine algorithm that has been chosen. So the next step is data preparation. Like I mean, we used to get raw data. I mean, that data is not filtered. There's maybe some missing values, and we have to prepare data in good form to like let the machine learn from this data. And machine will select a model. Then we have to provide the training to the machine. Like we will be giving the data, and we will saying this is the input and this can be the output. Then with this data the machine will learn, and then we will evaluate that model with the test data, because initially we have some data, like maybe if, you can say the 100 values. Then we will try to split this data into test data and training data. So we will supply training data to the machine, and then the rest of the data, that is the test data, then we will use to evaluate the algorithm. Then we will some reduce the parameter tuning, and the output value will be predicted. So these are just simple concepts to understand the machine learning. Then we proceed with various types of machine learning. As you would have heard, like it may be of basically of three types or four types, like supervised, unsupervised, and reinforcement learning. There's fourth category also, like semi-supervised learning. So you can see the diagram. These are three different types of machine learning. And supervised is like this is the task driven, because it's like is supervised, we as humans will be supervising all the data, and we will be supervising first to let the machine learn from the data that we are providing. This is unsupervised learning. This is totally data driven. This is task driven, and this is reinforcement learning. So we will learn this in detail about all these types of machine learning in the next few slides. So this is supervised learning. So as you can see that we are providing the machine learning algorithm with the labeled data. So labeling is like, as you can see, uh, this is our model. This is the machine learning model, and we are supplying the known data to the machine, and we are also giving the response to the machine that these are apples. So once we given the enough data to the computer or the machine, then whenever we supply the new data, then it will automatically detect that this is an apple. So this is a new response that is not provided by us, but it is provided by the machine. So as you can see, the algorithms learn based on the provided labeled data. So data is labeled because we have supply, we know the input. We also are providing a label for the type of data that is to the machine. Based on these labels, the machine learns, and if any future value comes, it will predict based on these types of learning. So we will further see what is the supervised learning workflow. So as I already told you, this is the input raw data. Now as you can see, there are different types of items or anything, and this is the algorithm. We are working as a supervisor. We are telling them this is the data, and this is the labeled response that we are also telling the machine initially. Then this data is being processed, and at the output we can see that a machine is able to tell that this is this type of data, this is this type of data, and this is this type of data whenever the new values come, because the machine has learned enough from the input data, and we have also provided the supervised learning, because we as a supervisor working for the machines to learn, and then after learning the machine will be able to tell what type of data we have provided when we will provide the test data to check the algorithm. So these are some common examples of supervised learning. Like I also would like to tell you there are two types of supervised learning. Also, I do not apply it, because this is two types of supervised learnings are like, one is the classification learning and one is the regression type of approach. So in classification, we are just like maybe classifying the data according to the learning values, and in regression, we will be predicting some value based on the data that we have provided to the machine. So these are two approach for supervised learning, and these are common examples that are being used in uh, they are popular, like email spam detection. We will then fraud detection, then image classification, like face recognition in Facebook. You have seen it gives you pop up. You would like if you want to tag anyone. Then score prediction. We will use the regression approach. So as I told you, if you would like to predict any value, then we will use the regression approach. Or if you want to classify the data, then we use the classification approach. So what is unsupervised learning? So as we have seen in the supervised learning, we are providing a labeled data to the machine. But as we know, usually we don't find the labeled data that we have to work on, and mostly we have the unlabeled data. So because unlabeled data is like we don't have any labels associated with the input data, like we will not supply to the machine that this is the apple, this is a cat. So in unsupervised learning, algorithm is fed with unlabeled data, and the algorithm groups or clusters or organizing the data. So it will identify itself. It will make a cluster of the input data, like what type of values it has, and it will observe and learn from the pattern identified by the machine. So this type of unsupervised learning it is totally data driven, because we are not supervising it. It is The output is only controlled by the data and its formatting. Yeah, you can see here we have the input raw data, same as the supervised learning. We have seen this example. Uh, but here you can see we have unknown output. We don't know what type of data it is because in unsupervised learning, we don't have any labels associated with it. So algorithm will be run processing, and it will be able to classify or make the clusters of data because in unsupervised it makes the clusters. So it will make the clusters or it will organize the data in this form. So these are different applications of unsupervised learning. This is like if you see on Netflix any type of videos, there some future videos are recommended to you, and they use unsupervised learning. Also, if you are shopping online, and then they are giving you also recommendation that you also should buy this because they learn from the history of user, like buying from the online store, and they will give you suggestion that people who buy these items are also buying these items together. We can also use the clustering of data such as user logs and issues, or we also would like to maybe sometimes research papers of similar domain we want to find out. So we can use the unsupervised learning because our data is not labeled in all these things. And the third type of machine learning algorithm is the reinforcement learning. Uh, in reinforcement learning, the algorithm we are making the algorithm learn by giving it a feedback. Like the machine is if the machine in the first time the machine is we are giving the data and the machine will tell its response, and we will give a feedback to the machine that it is negative response or the positive response to the machine. And if we are giving positive, it will learn that for the next second time that this response was positive and it should stay with this value. So our feedback will enable the machine to learn, and our feedback will reinforce the algorithm to make a good predictions after learning from its mistakes. Because once a machine will do any mistake, we will give the negative response, a negative reward to the machine, and it will learn from its mistakes. So see, this is the input, and machine says it's a mango. We are supplying the data for the first time. The machine says it's a mango. We will give feedback wrong. It's an apple. Then the machine will learn. It will just note it that this feedback was negative, and the it should be the actual value should be apple. So whenever for the first time we are giving the second time we are giving an input, it will automatically say it is an apple. So we are reinforcing our response to the machine, and for the next time it will learn from the mistakes that he has performed in the past. So, reinforcement learning has also some applications in gaming, financial sectors, and also in inventory management. So, we would like to maybe see an example. Uh, uh, to maybe let's see, like we have because if you take the example of students getting an admission into a university, so for selecting a university, we have to. So this is our problem. Like we have to predict the chances of a student to get an admission into the university. So in this approach, we will use the supervised learning and we will use the regression method to solve this particular problem. I will tell you why we are using it. So we have our aim is like a student wants to get an admission to a reputed university, and he has different types of score like maybe GRE score, English score, also statement of purpose, and a letter of recommendation, university ranking. These are the different parameters that we will supply to the machine, and we will try to predict the output. The output is we will predict the chances of a particular student to get an admission. So these are all the parameters. With this particular parameter of getting the chance, getting an admission, we will predict these chances of getting an admission into the university based on the student grades and other important documents like a statement of purpose, letter of recommendation. So we will use the multilinear regression method. There are two types of regression methods. One is linear regression method, and we will use the linear regression method when we have like the output is dependent on a particular one, only one type of dependent variable. But we here we have multiple uh, dependent variables, and independent variable is our predicting the chances, and we have dependent variables like grade, statement of purpose, and these all are the dependent variables. So what is regression analysis? This is the process of predicting the label dependent variable. Here in our case, the dependent variable is predicting the chances of getting the admission, and we will predict these chances based on the features, and the features are our independent variables. And we have our independent variables are like different input parameters like the grades of the students, the ranking of the university, his statement of purpose, the letter of recommendation, any input from which we can predict the chances of getting an admission. So what we'll do, we will try to because we know that in mathematics the linear progression of uh, linear methods, like if we have a line y is equal to mx plus b and with a slope, so that slope is called the regression actually. So we'll try to fit our curve to the data points, that the difference between the distance of actual data points. I will show you these things so you can ignore from for now. Sorry. So maybe I will just give you an overview how this is done. So I'm just trying to import the necessary libraries in the Python, the pandas library and machine learning sklearn libraries to perform the linear regression approach. I'm also trying to load the input data that I have in my prediction file. This prediction file contains all the input data. Data is like the grades of the students, the chance, the statement of purpose, research field, anything. So I will data dot head. It will just we will see the data, top data actually. If I see this, this command is showing the top data because we run the data dot head here. So this is the top data. We can see here we have supplied to the machine these inputs for this is, and we will try to we will use this as a dependent variable. This is our chances over mid that we have to predict in the future, but first we have to make the machine learn. And this is another inputs that we are giving to the machine, like what is his GRE score, what is the TOEFL score, what is the university ranking, statement of purpose, letter of recommendation, and what is the CGPA of the students. So based on these all these things, the chances of admission of a particular user is calculated. But first we will try to give this input to the machine, and we will divide our data to training data and the test data. And we will first with the help of training data we will make the machine learn from the training data, and then we will use our test data to check whether the machine has learned uh, accurately, and our test data will gets fit on the curve. So let's move ahead. So this is adjusted R square function that is used to perform the regression analysis. So I will not go into details of coding actually. So as you can see here, this is a data analysis of data set. We are trying to count. We have trying to calculate all the mean, standard deviation, and everything. What is the maximum value of data? What is the 75% of all the data? And as I told you, like first you have to gather the data, then we have to uh, perform the some data analysis. Like we should supply a clear data to the machine. So I'm trying to find the missing values in the data, and we will try to fill it because data should be clean when we are supplying the data to the machine, and it should be able to learn. So I'm checking for the missing value in the data set. So it is telling me that there are some values in the data sets that is missing. As we can observe that there are few missing value in this data, we will first insert some missing values. So this is the function fill na that is used to insert at the places where the values are absent, and we will try to make the data uniform so that machine can learn from it. So with the fill na function, we will try to fill the data at the places where the data is missing. As you can see here, we have used the mode function, and the mean value is supplied here, and also the mean value is supplied here because the university rating and TOEFL score and GRE values, they had some missing values, and we are trying to give the average value to those particular places where the value was missing. Then again, I'm trying to see uh, the data, top data, and also I showed you in the previous example there was some serial number at the head, and when we are supplying the data, it automatically creates the index of the data, so we can remove that serial number from the data input to create an unnecessary things to for the machine to learn. So I would first I would like to see the data distribution. So these are our all the parameters like GRE score, TOEFL score, university rating, statement of purpose, CGPA, research, and chances of admission. So I want to see the data, how the data is distributed throughout. So as you can see, our GRE score is like this. It has the highest value of 320 or something. At the this value, we have the TOEFL score. We have the university rating according to this value. Okay, so we are just trying to see how the data is distributed uh, along the data. I mean, so we are just trying to plot it. So now what we want, we are separating dependent and independent variable. We as I already told you that we want to predict the chances of admission. So we will take chances for admission as y variable, and all the other columns accept the chances for admission as the x value. So this will be our independent variable, and this will be our dependent variable y and x. So I want to visualize the data and analyze the relationship between independent and dependent variables. So I will try to see the dependency of our chances of admission to all these particular values x that are present in our admission file and our data set. So I'm trying to plot all these things. Uh, as you can see here, I have plotted all the values chances of admission with respect to our GRE score, TOEFL score, university rating, statement of purpose, everything. So I have plotted the dependent variable chances of admission with respect to all the independent variables that were there in the data set. So I mean, we can see from this the relationship between the dependent and the independent variables. Like here, it is like more like linear approach. Here also, it's linear approach. University rating is it's not showing the more of a uniform linear approach, but we can see here that as the value is increasing, the chances for admission is also increasing something. We can see here also, and CGPA also. Because with the research method, it is like the research paper. It is either zero, either one. Any student don't have any research publications with him. So this is also with the research contribution, the chances of admissions are not increasing as linear as these are increasing with this. So we can see here the relationships between the dependent and independent variables looks fairly linear. So our linearity assumption is satisfied. So we will use the linear regression approach, but here like there are more dependent variables, so we will use the multi collinearity approach. I will show you. So this is our variance inflation factor. I will tell you what is variance inflation factor. Like if we have multi collinear approach, like we have multiple independent variables and one dependent variable, and we want to see the like the dependence of, like we want to see that there should not be any particular variable, the independent one, from which the value of the dependent is changing too fast, because we want to see like it's not depending on a particular variable, so we want to calculate the variance inflation factor. So as you can see, it's a measure of collinearity among predicted variables within a multiple regression. So whenever we have multiple uh, independent variables, so we want to first calculate the variance inflation factor to check the dependency of the dependent variable on the independent variable. So it is calculated by taking the variance of given models. So here we were calculating that, and I will like to maybe show you the output. Yeah. So I calculated the VIF for all the features, and we can see here, if you read about the VIF, this is the variance inflation factor, and it should not be greater than 5, and it should, I mean, at the extreme also it should not be greater than 10 at least. So at 5 it is okay, but it should be as low to great with from 5 is possible, because here we can see it is dependent on GRE factor. The more, if it will cross the 10, if the VIF value for the GRA score will be more than 10, it will mean that our chances of chances of admission are like more than, um, for 50-60% depending on this variable only, and other variables are not taken into consideration. So we want our VIF score less than 5, and our VI score for this particular problem is less than 5 for all the variables. So we are good to go, and we can apply the linear regression method. And let's try to check it. So I have split my data set into training and test data. I already told you, like, we have to split our data set into training and test data. Then first we will train our machine with the training data, and then we will perform the evaluation of the learned algorithm on the test data. So I have split the test train data and test data, as you can see. Then I applied the linear regression approach. So when I find the score of training data, it was regression score of training data, it was coming out to be 84%, and a deficit R2 value. This is like a score to calculate the regression value. This was coming to around 83.85%, and when I applied the test data, the regression score was 75% and 73%, which is good enough to. I mean, it should be as close as possible, but this is also a good value. So these are the results. Like we saw that our test data was also fitting into the curve, and that's why the results were around 70%. So we trained regression model to predict whether a student will get an admission into the university based on different features. We have used multiple regression model because there were multiple variables that on which our chances of admission was dependent. So we assessed the trained model performance using R2 statistics, and after training, we found out that our model was achieving 84% R2 score and 83% adjusted R2 score on training data set. But on test data set, we found that our score was around 75 on the almost 75 on these values, which is like a significant score. Okay, so we have performed this. I will also like to show you maybe some applications of machine learning areas. We have already talked about the application areas of supervised learning, unsupervised learning, reinforcement learning. What are the application areas? So maybe in particular, if we talk about social media, internet, these are all the applications of machine learning, like image, video classification, speech recognitions, all these things. In medicines, the cancer detections, the illness prediction. These are also the applications area of machine learning. We are just applying the data, and we are able to predict the output from the data set. We have automations. You also know the e-commerce site. We have the product recommendations. We have dynamic pricing, as you have seen. Like whenever we there is a time that we people are trying to book the cab, and this is the like a peak time, so the prices of the Uber or the Ola goes high. This is called the dynamic pricing system, and this is also based on machine learning algorithms. In media and entertainment, we already talked about the recommendation system that are used with the help of machine learning only. We have security system, cyber security, video surveillance. These are where also we can provide machine learning algorithms. And you know that self-driving car, they are also the machine learning approaches, like for the object detections, lane tracking. So these, we can apply machine learning everywhere, and we have to select a particular model and particular type of algorithm. Okay, that's it, I guess. Yeah, thank you for listening. If you have any questions, I would like to answer now. If I don't know, I will just try to answer later.
Yeah. Thanks, Amit. Thanks for nice presentation. As stated, nice introductory talk. I would like maybe to ask something in the other direction. Let's call it that way. Uh, in which branch of machine learning are you specializing? Which field is your field here in ML?
Yeah, but as of now, I just actually I try to present something about for the beginners that like I do not present anything. But as currently I'm working on some genetic algorithms. I'm not totally devoted into machine learning, but it's like these are the things that I have learned from history, and also I'm currently working on genetic algorithm. That is also part of evolutionary learning. I'm just trying to apply my things into the machine learning. So I'm not from the healthcare side or something. It's just I'm working for the wireless sensor network, and I'm trying to uh, like implement our my wireless sensor data into the machine learning algorithms.
Okay, so healthcare
Yeah.
and can we continue for a moment? This wearable devices in healthcare plus machine learning. That's your aim.
Yeah, yeah. My actually working research is into the field of you can say the IoT, the Internet of
Mm-hmm.
Things.
Mm-hmm.
So I have to produce the optimization algorithms to reduce the energy levels of these sensors, and to increase the lifetime of these sensors. So I will try to implement machine learning into these things. So this
Okay,
is this is maybe related to wireless sensor network side.
sounds interesting. Though as we
Yeah,
see you stepping into the ground of machine learning, so it for you, how does it look? That you will shape this problem into the supervised problem, reinforcement problem. How would it like for you? Do you know already?
yeah. I mean, as of now, I have implemented some evolutionary approach. I mean, that is not totally into machine learning things, but I'm just trying to gather some data as of now to apply this data into the machine learning algorithm. So I think my data will be more terms of like non-labels, and I will try to use supervised learning as of now, maybe some regression approach or the classification approach.
Okay, thanks.
Yeah.
We have some question on chat, so actually, if you can go there and address them, would be great.
Yeah, okay, let me read. I could add two slides to your presentation yet. Why machine learning is able to provide proper output based on input data at all. Maybe some short info about valuation of internal functions, shape tuning. Okay, I think these are some suggestions that I should implement for the future when I try to give presentation. And I don't think these are questions. Yeah,
Ah, okay.
thanks Alec for your input. Yeah, I think these are good points.
Yeah, yeah, no problem at all. Of course, I
I
was
think I
trying to
think
say something, but I was muted.
yeah, I think you are trying to give suggestions rather than asking question. I guess
Yes, yes,
yeah.
exactly. Mhm.
Okay, okay. Thank you for the points.
What are
Okay.
your plans? Okay, I have a question. What are your plans about IoT? I mean, Internet of Things. Do you plan just to gather information using such equipment only, or you would like to process some data on edge also?
Uh, if I understood you correctly, you want to ask about my research work that I'm currently doing.
Yeah, because you mentioned that you are interested also in Internet of Things, and
Ah,
in short, also to apply it in medicine, right? Am I right?
medicine. You said medicine.
Yeah, medicine. Yeah.
No, no. I am currently working on a wireless sensor network. This is type of IoT, Internet of Things word. So
Okay.
I'm just, yeah. So it is not related to medicine part. So I'm
Hmm.
just trying to optimize the learning algorithm to make it energy efficient network.
Okay,
Okay.
okay. I
What?
Yeah.
actually mentioned medicine, so maybe that was
Okay.
confusing. Sorry, Alec. Got
Okay.
it.
Okay.
Okay. What type of sensors do you use? Do you have any experience, especially with medical in sensors used in medical or healthcare in medical
Uh,
environment?
I have no experience with I mean with the physical sensors. So as I told you, I'm working on the
Mhm.
algorithmic part. So I'm trying to just making the programs and try to run the algorithms, different type of some types like genetic algorithm, meta heuristic algorithms, to like I have maybe programmatically deployed some sensors onto a field region. It's not like I'm working with physical sensors and trying to get the data.
Okay.
Yeah.
Okay. Okay.
So
So
I'm
in this
just
way.
mainly, yeah, I'm just mainly into the algorithm part.
Okay.
Yeah.
Okay. Thanks.
Yeah. Thank you. You're welcome.
Okay, good. Amit, as you can hear, we also tend to have questions about presenter, about the
Yeah.
background. So that's we are kind of community, so don't be surprised here.
No, no. It's fine.
Mm,
It's good to be communicative and
yeah,
have
great,
good
great.
information.
Mm, so yeah, if anyone have any more questions, or you are willing to tell more about actually this IoT, uh, we can continue. If not, I think that will be it.
Yeah, I don't think there's any more questions. I guess.
Yeah, so maybe yet again myself. This, but you mentioned something about healthcare, or did I just set something off here?
No, no. Actually, I was trying to implement something, some applications related to healthcare only, maybe some drug discovery or some cancer research.
Ah,
So,
okay,
so maybe I will try to give next presentation into the healthcare field, how machine learning is applied. I was just trying to get some data and apply the algorithm.
okay, but that's a rather your research interest, right? On a site, this
Yeah,
healthcare applications. Yeah.
that's not my uh, current work field, but it's like I'm just trying to see how we can fit the data, healthcare data, also onto the machine learning algorithms.
Okay.
Yeah,
Okay. So I guess that's it. Amit, thanks again. Thanks for giving a speech here. Good luck with your endeavors and the plans for incorporating machine learning into your research. And yeah, hope to meet again at our
yeah.
meetups.
Thank you very much, Martin, for this invitation and letting me talk about this machine learning. Thank you,
Great, great.
thank you everyone for listening.
Thanks.